Hi, Arun.
Uh, Hi, Mithun.
Yeah, so we'll start in about 3 to 5 minutes. We're just waiting for Satyesa to formally host you, and then we'll begin.
Okay, yeah, good to know. Thanks.
Yeah. So, yeah, there's no technical issues from any side, right? So, have you
Uh,
checked your screen? Like, can you share your screen so that we can see that if it's working?
okay. Uh,
Yeah. Yeah. Yes.
okay, my screen is visible, right?
Yep. Yep.
Okay.
Hi, Arun. Good to see you after so long.
Hello, hi. Uh, I was just wondering who was.
This is Sneh.
Oh, hi, Sneh. Hi.
Hi.
Yeah, it's been a long time, I think.
Yeah.
I also see like few. I think Mira also joined from our batch. I think.
Yeah.
better you should start this session because it's already late.
Okay, I can perhaps do that.
Yeah.
Okay. So can you see my screen?
Yes, it's visible.
Okay. So yeah. So first of all, I would like to apologize for the last session. I think because I kind of moved it after a month. So due to some unavoidable circumstance, I have to do it. But then I'm happy that like we managed to find a slot today. So the presentation, what I thought, especially when I'm going to talk to designers, so probably I would like to give them a very different perspective about the recent technologies and or the which has actually impacted the automotive domain. Besides that, I will also talk a bit about different human factor challenges which has to be addressed, and there is a lot of opportunities, especially for designers. So the key aim for me today is to actually create interest among designers to start to get into the research domain and try to contribute in that area as well. So currently I'm working as a human factor researcher at Autoliv. So I have like a history where I started my career in design, and then I gradually progressed towards the human factors domain. So a bit about the background. I have started as an engineer, so as a mechanical engineer, and then I started to learn all the theoretical concepts in the engineering, and then had a passion towards design. So I went to pursue my design in from design program in IIT Kanpur from 2007 to 2009. And afterwards, I started to work as an industrial designer at Escorts Agri Machinery Group in Faridabad. So I've been there for 6 years. So when I started, it was a very small team, just two designers, and after that, I started building up a small team. So I was responsible for all the styling activities at Escorts. And also probably even few of our alumni also actually worked along with me in building up that particular studio. So I spent 6 years in the industrial design studio. I was leading the team there. And then we had different challenges, building all new product development, carrying out all the new product development projects. And besides that, also a lot of facelift activities. So that's the time when I started to understand or try to create or try to understand like how the human machine interactions is a very important area, because especially in tractors you have a very different operator cockpit levels where you have like different levers and different controls which has to be taken care of when you try to operate that particular vehicle, and then having a very smooth interaction between the different systems and functions inside the vehicle was quite important. So that's where I wanted to go and learn further how to actually like learn to design human interactions, and that's where I landed up in a design school in UK. It's at Loughborough University, and I did my master's MSc degree in human factors, where it was under the umbrella of design school. And so I learned all the theoretical concepts related to the human factors. So along with me, there are a lot of psychologists, and there are people like occupational physiotherapists, and there are many other people coming from different backgrounds. Of course, we do have a lot of designers as well who have been like along with me, was trying to learn this particular human factors domain. And following which, I got a job in Sweden. Then I moved there as a vehicle economics consultant for one of the leading truck manufacturers in Sweden. So I worked with them as a vehicle ergonomics consultant. So I was working in their new R series cabin, where they mainly looked at the different ergonomic inputs, and also from the design point of view, where they try to actually address different ergonomic issues. So I was working with the team, the physical ergonomics team there, and besides that, I was also working a bit on the some of the European projects, mainly looking at human machine, like designing human machine interactions for automated trucks. So I was working in some European projects, and that eventually landed up another opportunity at Autoliv. That's a southern little like southern part of Sweden, where you actually move to Gothenburg. So initially I was in Stockholm, and then I moved to Gothenburg, and then I started working as a senior research engineer. So it's basically working on all the research activities related to the automated vehicles, and also looking at all the carrying out different user studies and user clinics related to the HMIs. So I'm working there. I started at 2017, and I'm working with them at the moment. So Autoliv is one of the it's an interesting company to work with, because their key products are basically airbags and seat belts. Airbags is one of the very important product. Usually they try to inflate, for example, when a vehicle ends up in a frontal collision, usually the airbags gets inflated or deployed in actually 15 milliseconds, which is actually 8 times faster than the blink of an eye. So it's basically they are designing systems which will work only during the crash, and you also know that how many people usually face an accidental situation. So when they do, these systems have to work without any failure. So that's why I see this company is actually working on a very important part, like saving human lives. So I'm currently working with the research team, and we do have a biomechanic department which actually works on the different human body modeling activities as well. So it's a quite interesting and work, and also looking at how they design the systems, and how they manage to also take care of the user needs and so on. So for the today's presentation, the key focus, as I said, of course, I would like to create interest among designers to come to the design area, to the research field. So besides that, I would like to talk about a bit about humans. It's a bit, they are very quite interesting. And since humans and systems, when they interact, it's going to be a very uh, interesting or a challenging points there. Besides that, I would also like to talk a bit about the brain-centered hazard. This I listened from one of the webinars from a human factor specialist who talked about the brain-centered performance. Probably I thought might be interesting to share some of the insights to give you a broad understanding that how humans do possess certain limitations when they involve in certain activities. So how we can actually help them to design systems in a better way. And I'll try to wanted to give you some kind of an introduction to the automation in vehicles. So what's the current status? So what's happening with the automation levels, and how the vehicle manufacturers are able to adapt to that particular automated levels, and what is the current status and so on. And bit about the self-driving concepts, which is actually not new, but probably it started in 1920s. So just wanted to give you a quick history that how this whole thing has evolved, and also the level of automation, which how the Society of Automotive Engineers actually defined, and why it is so complicated. And that's why we need a lot of people, especially designers, to think it in a very different way, how we can actually present information to the users. And also some research areas in the automated driving, which I think is quite crucial, and we need a lot of investigations in that area as well. And finally, ending up the talk with the human-machine interface design, which is more to do with the design aspects. And that's also an area where you need to have a design background in order to come up with a very intuitive interfaces. So I would like to also touch upon that. And then finally, a few videos from the company side, at least from the promotional aspects of how Autoliv is planning to do or face the future. yeah, design us into research. That's the key aim for today in my presentation. So probably maybe someone can actually, I think you're seeing a picture at the moment which shows that there are people working in some place, in some parts of the world. And can anyone tell me what is the problem with this situation? Just a guess. Can you guess what is the problem with this particular situation?
The brain might have fall down and they're cleaning. I don't know. Just a random.
Okay, not bad. So probably it's a regular schedule, and there are, you could see the construction workers, they are working, they are building up or creating some barricades. But do you wonder that how they are going to take the truck or a van parked inside that one? So that's the thing. So it's basically, in the first place, many of us don't want to do mistakes in a regular routine, but of course people end up in doing mistakes even they follow a lot of protocols. So the reason why it happens is because it's basically the brain, or our system has been designed in such a way that even if you follow things from top to bottom, of course you will have some occasions where you end up in making mistakes, and these poor workers have done that. So if you see the risk involved in this particular situation is not that high. Of course they can figure out a way to remove the truck or a van from that particular location, but then it could be even situations where it ended up in causing lives. For example, I would like to bring up this particular incident which happened in 1987. It's called the Zeeburg incident, where a ferry has been capsized because of a human error. The reason, after the investigation, they figure out the main cause of this particular sinking or capsize, because the operator who's been in charge for taking care of closing the bow doors of the ferry, he forgot to do that. So bow door is nothing but it's actually a door through which all the vehicles or the passengers try to enter. So on this particular day, it was actually between from Belgium port to Dover. So when they tried to operate this ferry, the operator, he actually forgot, and then the ferry started to sail without closing their doors, open doors, and that's where the water started getting in, and then this cost a life of like I think it's 193 lives, within the fatalities. So, but when we started looking into into the investigation, it's because the operator hasn't, probably he didn't got enough rest, and probably actually missed it out, the particular protocol which he has to follow on that particular day. So the key thing here is humans do make mistakes. It could be low severity, or it could be like high severity, what you have seen regarding the Z work. And you could also like bring out a lot of examples, like the incidents what we have, or especially the Bhopal, the gas leak, that could be also caused by a human error. And still there are many accidents or which has fatalities which is caused by a lot of human errors and improper decision making. So again, this is quite it is well known. I think it was quite circulated in the social media as well. Can someone tell what is the problem with this sentence?
These written two times.
That's correct. Yes, that's right. So usually our brain tries to always take a short route. So it tries to trick us, which is not a bad thing, because when the brain tries to take a short route, it actually saves energy. So once our brain saves energy, it's quite good, because it doesn't gets into an overloading the system. So probably I'll be talking more about what is called like a slow brain and a fast brain in couple of slides. So it's always a good thing that the brain is trying to save energy, and it is always taking a short route, and we humans try to read using our brains, not with our eyes. So that's also like quite one example where you can actually see here. In a similar way, this is also another example where I think most of you would have figured out what exactly the sentence when you started putting in the words. Like as I said, your brain starts to take the short route. It tries to figure out patterns and associations and try to find what exactly is being communicated there. So I hope everyone figure out, can you read this? You aren't reading this, and what are you actually reading? So coming to the interesting aspect of human brain is actually two things. There is one usually which is termed as system one thinking and system two thinking. Probably in a simpler manner, we call it like a fast brain and a slow brain. So the fast brain always try to be active. Like for example, let's say that I would like to take an example from this book, which is called Thinking Fast and Slow by Daniel Kahneman. So probably you could actually see that, for example, if you're going to meet your boss who is quite angry, then I think from the facial expressions, you could actually sense that he or she is angry. And you could also even predict what will happen for the next few moments. Like, for example, what kind of words he or she will start to utter and so on. So it's basically a brain tries to find patterns, associations, as I said earlier, and it can actually even predict situations. So that's the first thinking, which actually happens, which is quite effortless. It happens so quick. But at the same time, when I ask you, could someone tell the value when you multiply by, let's say, a random number like 189 cross multi times 234? So that's where the whole system two thinking starts to come into picture. So where your brain starts to compute. So then it's a slow conscious process where your brain starts to recall your cognitive learning, what happened in your school, like how to do a multiplication of 189 times 234. And then you start to do that activity, and then of course it's not only your brain involved in, of course your muscles and your whole body is involved in. And then you start to do the calculations, and once you're doing the calculations, probably if someone is looking at your eye, they can actually see that your pupil is being dilated so much. So it's because it's a conscious thinking which is happening. So once you do that, and then once you finish the figure out the answer, once you finish that computation, then it goes back to the normal state. So it's the beauty of the brain that when you have something which makes you more conscious and something which doesn't makes you more conscious. So it's, as I said, the whole purpose of the human brain is to save energy, and it tries to save energy in most of the situations. So the problem happens is that when the brain starts to take a fast route or like a quick decision, the thing is we might miss some of the important events which is going to happen in a specific situations. For example, one of the interesting research studies which looked at the naturalistic driving data of many drivers, they figured out that the people who missed the red lights, they had a chance to see the red lights. They did see the red lights, but then still they missed it, and then they actually went on driving further. So the reason is because that's where you see this the fast thinking brain is not doing well. On the other hand, you need to have these two systems in place, and this has to be work hand in hand. So that's why it's important to understand that as a designers, when you start designing things, especially when you start even making a small icon informations on the cluster, you have to be very clear that how you are going to design according to the human needs and human limitations. And as I said, the brain is quite tricky. It tricks things very easily. So let's say that so we do understand that humans have a certain limitations. So that's where a lot of engineers and a lot of people are thinking, okay, let's start building up automated systems because that can take care of the entire situations. But that's not the case. Well, it's a clear good examples which we have seen that the two deadly crashes happened in 2019, especially with the Boeing 737 Max. As I think it was a tug of war between a pilot and the MCAS systems. MCAS is nothing but the maneuvering characteristics of an augmented system. So in simple way, what it does is when an aircraft or when a plane takes off, probably there is a sensor which actually detects the angle of attack, which is basically the tip of the nose. And then it tries to sense, provide informations to the horizontal stabilizer. Like as you see on the picture, you have something on the tail end, which I just call a stabilizer, which actually adjust according to the which provides a sufficient lift for the aircraft to actually start taking a particular, like reducing the pressures and so on. So what happens is that in this particular case, the sensor which actually detects the tip angles tried to provide, I think it provided a wrong value to the MCAS system. So the MCAS system started to make those adjustments, like as you can see in the picture on like the point number 5, where the MCAS system was trying to pull down the vehicle because of the faulty sensor reading. But on the other hand, that in reality, that was not the case. So the pilots had to intervene and try to resolve this problem, but that was too late, because every time when they tried to intervene, the MCAS system wasn't keep changing according to the sensory angle. But that's how it is being designed. So, and then of course this actually also brought in a lot of question that if we start to rely on automated systems, that they will take care of or take care of the humans, especially in situations like these. Probably it's not going to happen. So that's one example we see. So relying on sophisticated algorithms is also not good. So that is the example I would like to, tell you, that probably it's not even automation can help in situations. So we have to have a human and an automation working together, and the main role of automation should be like assisting the humans rather than taking over the entire responsibilities or tasks of humans. So moving on to the automation in vehicles. So basically, why do we do automation? Why do we need automation in vehicles? It's nothing, it's quite straightforward. We would like to reduce the number of vehicle accidents happening. And then, as you could see, especially in the like aircraft crashes, you see like one in almost like 90,000 compared to the 1 in 112 accidents which happens in the motor vehicle crashes, out of which, if you see, the 94% of the crashes are caused by the human or the driver related errors, especially the decision making and the performance errors. I would like to strengthen the point here. Yes, humans do make mistakes. Their systems are designed to make mistakes, so they will do that. And another statistics from the Indian context, I also figured out that like in 2018, it's almost like 151,000 cases as actually fatalities have been reported. It's just the road accidents happened in 2018. So considering all this, so probably at the moment, what the automotive OEMs are thinking, maybe automation is a good solution to reduce or to save lives. And that's where they started to put in a lot of effort to coming up or building the automated systems that can improve the safety and the quality of life. And of course, it's also the comfort. The moment you start typing automated vehicles in Google browser, you could actually see a very interesting concepts floating over there, like from sleeping to having a regular discussions. And at least from a human factors perspective, I'm going to tell you that that's not going to happen, because it's a lot more research has to be addressed before we see those things coming into reality. So moving on to the self-driving cars. So that's the research area I've been working on at AutoLive. So probably would like to give you some small brief history about how the automated vehicles have been evolved. So usually people call it by different names: autonomous, self-driving, fully automated. But still there is a standard way of defined by the Society of Automotive Engineers, which is nothing but actually, when you have a self-driving cars, it means it can drive by itself. It can handle situations, traffic situations by itself without intervention of the human driver. But of course, these particular domain, this particular operating domain changes from different levels of automation, which I will explain you in a while. So when I look at the history, the self-driving cars concept started to evolve in 1920. It is actually from the Photonic Phantom Cars, which is actually a group from GM. They started to remotely operate the cars through the radio communication waves. This was some example, like the toy cars for the kids, what we have these days, like it was remotely controlled. And following which in 1956, it was GM who started to define something more like having an electronic strip on the highway beneath the car, which can actually, so that the car can actually drive on that particular route. Of course, this is something which is also taking a lot of consideration these days, to have a separate lane for the automated vehicles, so that the vehicles can actually, for example, if you have like 2 lanes in a highway or a motorway, so probably you can have 1 lane which where the is dedicated only for the automated vehicles. So this was, but of course they are trying to control the different cloud sources and also the different other electronics, rather than what was present in 1956. So following which in 1980, it was from the Carnegie Mellon University, where they started to define or build more sophisticated algorithms which can actually capable of doing the routing and also avoid obstacle detection and avoidance. And I think the more a lot of evolution started happening from this Prometheus project, where they started to build the prototype cars, which has features like the lane keeping and also the cooperative assistance, and also to try to have a more enhanced vision capabilities and also the intelligent adaptive cruise controls. And slowly, then Amazon started to use machines like robotic machines inside their shop floor. So it is basically like it's only a controlled environment, where they thought they could actually use these particular vehicles, which can lift up to 1,500 kgs. But of course, this is not to do with automated vehicle, but at least show the concept that in a contained environment, you can actually have your own vehicle which keeps traveling at a particular path. And then after that, that's where the famous DARPA challenge, which actually started. So that's where a lot of universities and OEMs like trying to participate and build a driverless cars, and that's where the winner of this particular contest was from Stanford University, where they started to use machine learning techniques to build vehicles based on obstacle algorithms, obstacle detections and forecastings, and also like different other, they used multiple sensors to handle the vehicle for the different situations. So, and then from the Stanford University, I think they had a collaboration with Google, and then they started to refit the Toyota model. And this was the first one which was actually being driven on roads, which has been testing the automated vehicle features, especially the obstacle detection algorithms. And then probably this was again probably published in most of the newspapers as well, where the Google started to build their own cars and their algorithms. Like they had a algorithm which can actually do a 3D map of the entire things in front of the vehicle, and probably able to do a very depth recognition. And then so for example, you need to have a multiple routes to make the vehicles to drive the same route again and again, to have to actually enhance the algorithm features. And then that's what Google, I think they drove nearly like 7 lakh kilometers, I think. And then so with the current capability of having high definition image processing features, and also with the sophisticated algorithms, I think today's manufacturers are able to provide vehicles with having advanced lane keeping and assist features. And good example is basically Tesla, and they have their own autopilot features. And of course, many of them are trying to also investigate deeper into neural networks and so on. So that's about a quick from the history where it has evolved from 1920 till now. But then people start to realize that we should have some kind of standards for these vehicles, because otherwise it might be a bit hard that each manufacturer has built their own vehicles. So that's where the standards started to coming in place, and the Society of Automotive Engineers, they started to define the different levels of automation, and then what are the different features that should actually support the different levels of automation. And probably I can go to this one, so which is usually called as the levels of automation, and it changes, it varies from level 0 to level 5. So level 0 is nothing but the manual driving, what we have today. And so level 2, it's where you can actually have certain features, but still the human is actually responsible for most of the driving tasks. So these are like quite assisted features, like the automated braking systems and like EPS and cruise controls and so on. But then when we move on to level 3 to level 5, that's where things gets a bit more easier. You just say that the vehicle is responsible for the complete driving task, and the the driver's role is just to monitor the system. And some occasions like level 5, where you don't need a human intervention, that the vehicle can handle the entire situation by itself. With the sophisticated algorithms and so on. The interesting part here is level 3. So that's where actually the human and the vehicle have to work hand in hand. So that's where the complexity comes into picture, because there are certain occasions where the human is responsible, and there are certain occasions where the vehicle is responsible. For example, like if you're driving in a motorway and you activate the level 3 automation, and then if there is any construction work which is going on, probably the vehicle should able to do the lane keeping or the lane change by itself. But then in some occasions, if it fails to do so, then probably it will ask the driver to intervene. So that's where it gets tricky, because for example, if you imagine that you are in a level 3 vehicle, you're driving, and then you're working or you're looking at your phones, watching some videos. So probably you are completely out of the loop. So you don't know exactly what's happening. So that's the term which you use for the situation awareness. So basically, it takes at least maybe 2 to 3 seconds for your brain to understand like what exactly is happening. For example, if the level 3 vehicles gives back a control with less than 3 or 4 seconds, then probably you won't be able to take over the control, or you don't have a very good performance there. So you will end up in a crash. So that's why there is a lot of research which is going on in trying to tackle this particular situation where the humans and the vehicles try to work hand in hand. And the level 4 and level 5 is quite easy, because you define from the beginning that the vehicle is responsible for all the driving related tasks, and then there is no need for the humans to intervene. But then without reaching level 3, it's a bit hard also to go to level 4 and level 5. So when coming to the human factors, so that's the one research, or that's the area which actually tries to understand how to design systems based on human needs. Of course, if you could see like a aircraft cockpit, that is one of the complex systems. You can actually see the number of dials and gauges, and then different informations coming from that particular system, and the pilot have to actually handle most of the situations. So it's not a very easy. It's actually, it involves a lot of complexity when you actually try to design cockpits or design different systems, especially in the aviation industry compared to the automotive domain. But I think because since automotive domain is also like evolving more into the automated vehicles and so on, I think things are getting complicated, where the drivers don't possess the same level of skill sets what the pilots have or possess. So that's why we have to make systems which are more easier to understand, make it more simpler. So that's why the human factors is very important and crucial, where they try to understand or design the systems based on the human characteristics. Like as I said, the brain tricks us in certain situations, right? So probably try to take care of all the inputs, how to design systems so that they can perform, both the human and the automated systems can actually perform well. And then the domain which, or the area, the field which actually investigates a lot, is basically human factors. Of course, you have a widespread in the industry, like change varying from aviation to automotive domain up to the rail human factors as well. So the other part is, as I said, we could not also rely completely on the automation. So one example is already out there, which is usually termed as the ironies of automation, which is basically, the good example is the Tesla drivers falling asleep behind the wheel when they activate the autopilot features. So this is what will happen if you have these vehicles in the market, where people will enjoy those features, but in the end, they also forget that they are responsible to do some certain tasks. And it is quite evident. Of course, the vehicle can do something, provide some warnings to the drivers, and it can bring back the attention, but still, when someone is trying to sleep, that is basically an exponential function. So probably you will fall asleep within 2 to 3 or within 1 to 2 minutes, so quickly. So that's where there is a lot of research which is needed to figure out what is the best way to inform drivers about these particular situations, and also if something goes wrong, how to design systems which can actually doesn't cause fatalities. So Yeah, that's one of the downside of automation, where it cannot you cannot rely on it completely, and somewhere you need to have humans to actually be in place, and also to understand the system's behavior, how it should be, and also understand their responsibilities, what are allowed to be done in an autopilot when an autopilot feature is activated. uh, there are a couple of research challenges in this area. So one is basically over reliance and trust, which is nothing but the humans, we tend to rely on systems very easily, very quickly. So that's the reason why you could see the Tesla drivers are like falling asleep inside these vehicles. And the behavior adaptation, as I said, these systems, for example, in a cockpit for the pilots, it's something very highly skilled job compared to the one what you're going to design in automated vehicles. Probably you need all drivers to have an adaptation to their behaviors and also adapt to their systems. And of course, the systems have to adapt according to their drivers' behavior as well. Then automation misuse. This is quite common. This is like a product misuse, that which is quite, we could see a lot of products designed out there can be misused for different purposes. And the same thing will happen here as well for the automated vehicles. And the erratic mental workload, which we usually say that, for example, if the vehicle is taking care of the complete driving tasks, so the humans will get bored. So probably they will engage in some different activities. And then let's say that you are watching a video, and if the vehicle is asking you, please take over control, then probably your brain will like experience the maximum workload at that particular point in time if you don't react quickly. uh, the authority transition is another one key research area, where when to inform the driver, or when to provide the authority to the driver that he has to take over the country, or she has to take over the control. And the same day, when to hand over the vehicle to the vehicle system. So there are like a couple of things where the communication is happening between the human and the systems. That's also where a lot of research is actually looking at, which is termed as transfer of control. So that's also one area where we could see like a lot of ways we would like to communicate to the driver that you are responsible for this particular tasks, and please do take over when you reach the limit, and so on. And there is another things which is at least from the human aspects, again, it's called motion sickness, and also mode awareness. So I'll be talking a little bit deeper into this mode awareness and motion sickness part in the coming slides. So yes, the over reliance and trust, this is a very good example which you already covered. So in the first place, the humans do not question the automation performance. They will straight away trust the system. And still now we don't know how much level of trust we should actually have with these systems. So it's basically, is it we should trust the systems too much, or is it we should have an optimal trust with the systems, or we do not trust the system at all. And so there is a as usual, like there is a wrong assumption that the technology will intervene. Of course it won't, because it's again, it's a system. It is based on different sensors. So probably if you're driving on a snowy or a foggy road, the sensors will fail. So probably it means that the humans are trying to start accepting the system very soon than what the OEMs are like actually expected to do so. And then engaging in the secondary activities, which I mentioned, people will spend time looking at different things, watching videos. So probably even there will be a very detrimental effect on their situation awareness. So when someone asks, when the vehicle asks to take over the control, probably they won't be able to do that. Again, the automation misuse, as I said, it's getting common. People, especially the Tesla drivers, they're falling asleep. And then too much trust in the secondary uh, engagement tasks. And of course, like the countermeasures for all these things is probably we need to have a different way to actually provide training to the drivers, especially for the automated vehicles. So that's where the OEMs also trying to address, especially the younger generation of the population, where they will be like more exposed to the automated vehicles, probably trying to rethink on the way we actually provide licensing to these people. And of course, there are like a lot of other technologies inside place where you can have multiple cameras inside the vehicle looking at your eyes. And also there are like different sensors which could be in place, which can actually look at, which can collect data from the physiological component and then try to estimate so what driver state you are. It's quite fascinating when you start hearing about these words where the vehicle can actually understand you, at least from the physiological and the cognitive perspective. Of course, there are a lot of research which is happening in that area, trying to figure out how to actually understand. Especially there are interfaces like which is called brain neural interfaces, where you actually it can even help to understand when exactly the driver is going to fall asleep, and then probably it can actually provide some countermeasures. So monitoring driver and also providing a right level of attention is also quite crucial. So this is one interesting concept from Volvo 360. It's called 360C, and then I think it was presented last year. You could see how like the design has been evolved. Of course, it was interesting to see someone can actually use the vehicle interiors in a very different way, which is not in the current system, the current situations. But of course, you could actually use it for work, for sleep, and so on. This looks so fascinating, and of course, everyone wants to have this. But in reality, I think there is a lot of challenges in reaching to this particular level of but reaching to this particular level. So which I said, like one main thing in these vehicles is called motion. Probably the human factor challenges will be the motion sickness, which is basically like when humans exposed to a different level of motion. So probably your brain will starts to, or probably you won't get used to that exposure, used to that particular level of motion. Probably you might fall sick. And then this could be like, for example, the picture what you see there. If you keep looking at it for more than maybe like 10 or 20 seconds, you might feel a bit dizzy in your eyes. Of course, this something which is actually problematic to humans. There are like different sickness people will experience when using different systems, especially when there are things like when people get sick when they use when they like travel or take a ship or a ferry. So the one interesting thing about the seasickness is basically people get used to it. Like for example, if you're sailing in a ship, probably you can't break that particular journey, so that your system gets adapted to that sickness. But then when you're driving in an automated vehicle, you're not driving in first place, and then probably you're engaging in some other secondary tasks, and then probably you might encounter a different level of sickness, which is probably motion sickness. And this happens because what you're seeing and what you're feeling is not going to be the same. Let's say that if you're driving in this car and then you are looking or reading at the books, so probably your eyes will tell you that you're looking at the book, a particular sentence, and probably your body will say that you are in motion. So that's where the conflict which happens within our vestibular system, which actually will tell you that, okay, you're going to fall sick. So probably in another couple of minutes, you will fall sick. So this is one of the another key research area where a lot of researchers are trying to address that, how we can actually reduce these sickness levels which will be induced by these particular system features. There are a lot of factors involved to have this sickness, starting from age to the driving scenario, and also using a lot of displays inside the car. You could see there is a lot of, when you see the automated vehicle, you could see there is a different level of how people are designing things inside there, like having a multiple screens and so on. So probably those all will have a detrimental effect on how we are going to use those systems at the end. Uh, uh, Another interesting thing here is actually, this is a particular picture from a rally driving. So one interesting area or one interesting observation is basically the rally drivers, who's actually the co-drivers who actually read the pace notes. The pace notes is nothing but like it actually provides a guidance to the driver that when exactly he or she is going to have like a left turn, a right turn, and so on, and how how the route is going to evolve in the next few minutes. So this particular co-driver, of course, the rally driving is they drive in a quite high speed. So this particular co-driver doesn't feel any motion sick. The reason is because once he starts reading, even though he's not driving, but once he starts reading that it's going to have a left in another 2 minutes, going to have a right in another 3 minutes. So it actually prompts the brain to start thinking that like you're going to take a turn left or the right. And then so that kind of an anticipation actually makes people not to fall sick. So that's why if you see most of these systems are trying to have an anticipatory displays inside these vehicles, trying to explain to the drivers that what the vehicle will do in another few minutes. So it's going to take a right turn or it's going to take a left turn. So these are some of the very interesting design space where we actually lack very interesting concepts. So probably we need to have more creative designers to actually help to contribute how to communicate or how to design features and systems which can actually tackle all these human factor challenges. So when it comes to the design role, of course, there are ways you can actually handle the motion sickness. There are a lot of, as I said, one of the researchers was working on coming up with some design guidelines, like when you build these vehicles. So the first thing is basically you need to have a lot of room in terms of visibility, that probably your vehicles have to be, your shoulder lines have to be much lower as possible and try to have a high daylight opening. So at the end, it has to be like transparent as much as possible. That's where you can actually sense or you can actually predict cues from the environment in as easily like from the environment, and also understand the situation awareness, what is happening and how the vehicle is handling the situations, especially the different context. So these are, but of course these are just the guidelines, which is basically came out from the research that how or changing some of the certain parameters of the vehicle could actually help to realizing the automated vehicles or automated vehicle features possible for the current vehicles. And of course, when you also see the seating position inside these vehicles, would have seen multiple concepts where people are reclining and people are sleeping and so on. These looks good on paper, but probably, as I said, there's a lot of implications when it comes to situations where you have to intervene, or when it comes to situations where the vehicle actually uh, fails to do the way it is expected to do. So that's where you need a proper, especially in terms of seating position, because today's systems are designed based on the driver seating positions, but then the automated vehicles, you have a multiple seating positions where that's going to, still there is a lot of things to be realized to make this thing feasible in the first place. So just the last part here, which I mentioned about the human machine interface. So this is another area where designers can contribute a lot. So human machine interface is being seen as one of the growing or the important part in handling the human factor challenges in automated driving. So it's nothing but actually a kind of it's an interface which is basically a communicating medium between the vehicle and the driver. So one example here, which I mentioned, is just having informations in the right place and the right time, providing the right information. For example, you have seen systems where if you get a phone call inside your vehicle, then probably your entertainment system like reduces its volume and so on by itself, right? So there are like a lot of systems actually which can be designed, and of course, if the vehicle is going to ask you to take over the control, then probably you need to highlight that information in a better way. It has to be aesthetically appealing, that's for sure, but at the same time, it has to be really functional. How to, so that because this is the one which is going to cost lives, so probably you have to make sure that you design systems or provide things in the right time in the right location, so that the driver is able to perceive that information and do the necessary action that is required from him or her to do so. Uh, so as I said, it is actually an explicit or an implicit communication platform where you could actually see or inform the driver and the vehicle like a medium which they communicate with each other. And so when you say HMIs, it basically comprises of all the vehicle controls inside the car. It could be anything from your steering wheel to the brake pedal, and of course interacting with the cluster screens and so on. So everything has to provide the right level of feedback and also provide information to the drivers on the system behaviors and so on. one interesting thing, what's happening with the automotive domain, especially for the HMIs, is that actually I would like to bring this from the Professor Oliver Kotzen, who's been working on this commonality in HMI designs. So what you see here is basically a logo for activating the adaptive cruise control and the lane keep assist. But you could see now there is each manufacturers have their own way of presenting informations. So you could see subtle changes in different logos which is being used. And for example, if you're a Norway's driver who's been driving, let's say BMW, and then you're switching over to some other vehicle brands that probably are taking over, renting a car from a different brand. So probably you might have problem in really understanding so what exactly this particular logo or the information is communicating. So we do see a lot of commonalities in vehicle these days. For example, if you're traveling to Japan or England, or probably you can start driving a car there because you know there is the car has a certain controls which are like common in place, like steering wheel, brake pedals, and so on. But in terms of HMI, there is no commonalities as of now. People, as I said, it's just building their own designs, and it might complicate things when, of course, when you're going to rent different vehicles. So that is also one thing grabbed a lot of attention, that how designers can actually make this particular task much more simpler so that it is easy to understand and also makes it efficient for the users to understand. So this was the concept from Autoliv, so where we actually do a lot of investigation on these certain areas which I talked about, especially on the mode awareness, which is basically, you know, it's when you have a vehicle with different levels of automation. So each level of automation expects you to do a certain tasks, but then you should also understand what kind of tasks and how much time you have, and so on. And this changes from each levels. So I think it was actually they had a problem when they introduced this particular system in aviation industry, and I think Don Norman did a lot of work in this area, like looking at multiple modes. For example, like if you have a device with multiple modes, so probably there is a cause of mode awareness, which is nothing but like for, let's say that you activate a level 3 feature in the vehicle, and then from a user's perspective, you will think that you are in level 3 feature, but then the vehicle might be in level 2 feature. So probably there is a mismatch between different modes. So the activated mode and the currently available mode. So that's where you have a problem when you have a system with multiple modes. So probably we need to provide a clear, distinct information to the drivers, how in which mode the vehicle is currently active now. So yeah, that is quite evident in the aviation industry when they had introduced the autopilot features. So the pilots started thinking that the vehicle is in autopilot feature, but then actually the vehicle, the aircraft is in autopilot, but then the aircraft was actually in a manual mode. So they had some problems when they introduced. The same thing will happen with the automated vehicles when we start introducing these features. Uh, so one thing is basically the mode confusion, as I explained. The user's mental model doesn't matches with the system's mental model, and that's how you see a lot of things happening with the Tesla cars, where you just figure out, okay, so the pilots still, the driver still assume that it's the system is in particular autopilot feature, but some occasions where they just think the vehicle is not in that particular activated levels. So these kind of confusions might actually also arise when you have these multiple modes. So just the last bit here. So as I said, humans tend to make mistakes and they do have limitations. Our systems are designed to be working in that way. Our brain keeps tricking us most of the time because it has to save energy. Most of the time we take decisions based on the fast system on thinking, which is basically the fast brain. But there are situations where we need to also have the level 2 thinking which is in place so that we can have a very good performance at the end. And also I think I just talked about the automation ironies, where you see how people are misusing this particular system features and what we expect the users to do in these vehicles, but then at the end in reality you could see what they're actually doing. And also we talked a bit about the different self-driving vehicles, especially the evolution and also the research opportunities. And of course, HMI is one of the key area for designers. So there is a lot of opportunity to start to investigate like how to design or address challenges like mode awareness, transfer of control, and then behavior adaptations and so on. So I think that was the presentation from my side. Just wanted to show two videos from my side before we start to move on to questions. Okay.
What if your car knew when to drive itself? Z-Force Drive steering wheel can make that a reality with the capability to detect precise hand location and gesture recognition. Simply by removing your hands from the steering wheel, the vehicle knows to start driving by itself.
Auto drive activated.
The steering wheel is used to communicate with the driver, so safe transitions for autonomous driving can be obtained. If the driver fails to take back control, the vehicle senses that the driver does not grab the steering wheel, so it assists in changing lanes to avoid the obstacle.
Warning, driver attention required. Auto drive deactivated.
Z-Force can also make our behavior in the car safer. A simple tap on the touch surface can accept or decline a telephone call, and a long press can be applied on the steering wheel to increase or decrease speed.
Auto drive activated. Warning, driver attention required.
To have a safe stop, the vehicle warns the driver to take back control. The vehicle senses that the driver does not grab the steering wheel, so it slows down to a stop and gets out of the main traffic lane.
Auto drive deactivated.
The #1 cause of traffic deaths is human error. Z-Force Drive steering wheel can help saving more lives.
Yeah, so this was from the Z-Force, but there is one more video which at least from the promotional aspects. So yeah.
The ball joint on the front of the car just broke and they ended up like crashing into the car in front of them, but luckily it wasn't a very high speed.
I guess he hit the brakes pretty late and he slammed into the back of the car.
There is 1,350,000 people dying in car accidents every year worldwide.
That is something that we have to do something about. More than 50% of people that are killed in the transportation systems, they are outside of the car. While we are doing huge improvements in protecting the people in the cars, there is still a big opportunity for doing more. Since we are talking about the global level and we are talking about high numbers, we have to collaborate. We cannot do it alone. We have to take into consideration the infrastructure, the protection in different transportation vehicles, but also the behavior in traffic.
Hi, how are you? I need to talk to you. Sometimes I'm on the phone during my whole commute, which means from door to door, I'm going to be answering questions. It's quite distracting.
As a parent, I don't think you ever get as much sleep as you would like to.
So in order to really make a change and to change someone's behavior, first of all, we have to understand what is your behavior and how can we change it in a good way. It also requires that we have a lot of data in the background to base our judgments on.
One thing we're doing is, we try to help individuals avoiding risky situations by looking into different data sources that pinpoints how the situation looks, together with how the user is behaving. Then we can nudge that person into slowing down, for example.
Then it's also about providing information on which route is the safest one. Do we know particular points where you might need assistance when you drive? Do we know things about you that might be necessary for providing the right support when you drive?
We have friends that have died in car accidents, and you know how big is the tragedy. When there is one person dying in a car accident, it's too much.
Okay, so that was it from my side, and I'm happy to have some questions. Hello, sir. Good to see you.
Good to see you too. How are you?
I'm good, sir. Hope you're doing it as well.
Right. I'm sorry I missed the first part. Something came up with, so we had to rush actually.
Okay, sir.
Then I'll just watch the recorded video.
Okay, sir.
So you're right now in Stockholm, right?
No, sir. Actually, I live in Gothenburg at the moment. I used to live in Stockholm. So,
Okay.
yeah.
Okay.
I moved to Gothenburg.
Good. So let's see if there are questions. Yeah, you have one question by Nikhilesh. Says, how is automation decides how fast it should go? In how many years we can expect to buy a level 5 automated car in the market?
It's a good question. Well, actually, how how is automation decides how fast it should go? Actually, it depends on several variables, I would say. So starting with, of course, it depends on the infrastructure. For example, if, as I said earlier, like if you're on a motorway lane, which have like a dedicated lane for the automated vehicles, so probably we can control the speed. But there are like research ongoing to look at if actually the vehicle starts to drive the way the particular owner or a driver is going to drive. So it's quite adaptive. So, well, as I said, it depends more on the infrastructure. You could have it like between 80 to 100, but of course, if the infrastructure supports it, then probably you could have quite high speed as well. In how many years we expect the level 5 automated car in market? As I said, it's the concept is already there. As I shown the one from Volvo, it's already been there, and people are, I think, because level 5 is quite easy to design. As I said, the humans is not in, humans are not required to intervene when something goes wrong. So that's easy. But then, as I said, it might take another, maybe like, according to me, probably it'll take another 20 to 30 years at least to have in market, because we need to address the other factors, like I said, the infrastructure and also the connectivity, because that's more important for these vehicles. And then onto the sensors, as I said, if you drive in a foggy, snowy road, these sensors could eventually fail. So we don't have a robust technology for that. So I hope I answered the question.
So I was talking to some of my friends who are in the automotive industry and just telling them that, I mean, they were telling me that, I mean, generally when you are designing, I mean, particularly in automotive industry, you need to think at least 15 to 20 years in advance.
Yes, sir.
So
That's
that's
right.
something which is very important for the students also to know. I mean, because I mean, that's how one really, because I mean, I think by the time you start developing the concepts and it actually reaches the market,
Yes, sir. That's right. And the point for me today is also to emphasize more on the research part, like before we start to make some sketches and so on. So probably I would emphasize that, like, yeah, try to dig into a lot of research, try to figure out how the research is being done and what kind of findings is being reported there, and try to use that. So that gives a very good base for, like coming up with the different concepts at the end. So that's what I have learned. Like, so research really supports a lot for to visualize concepts for the future vehicles, I would say.
So, what would you like to suggest to our students, those who are interested in automotive industry?
Well,
Themselves.
Yeah, I would say it's it's an interesting era for automotive industry, and besides, as I mentioned, like besides exterior and interior designing, so probably as I mentioned about the HMIs, which are like a growing importance, and I would see a lot of designers have been working in that domain. So I would suggest take up some, even the master projects, thesis works could be in one of these domains where they can actually look at, let's say that if someone is designing a transfer of control part in automotive domain, then they can start thinking on that line how to create concepts for that. And then they quickly do an evaluation. Like, you don't need a very complicated setup. Of course, if you have your own automotive game with all the controllers, so probably you can invite users or try to test it. So do a lot of testing, I would say. But as I said, the main you have a lot of opportunity now to evolve or to be a part of this growing HMI thing in the automotive domain. So that could be one area they can actually focus on.
One more question, I think.
Are the economical cars still allowed to be manufactured without safety features like airbags, ABS around the world? So if I understood correctly, like, I think most of the cars do have the safety features, airbags and ABS. As I said, it depends on the population. Like, as I said, even for me, I really like driving. So probably I don't activate my ACC unless it is required. So it's hard because at least for the younger generations, it's going to be different. So probably they have exposed to a different level of things from the beginning, at least from the gadgets to the operating system, what they're going using. So still you will have a chance. Of course, as I said, there will be vehicles with the level 3 features, but of course there will be vehicles with level 0 features as well, because as I said, we can't rely on the sophisticated algorithms completely. So you will have an opportunity to drive. Like, for example, today you're driving and you have an opportunity to use autopilot, but then in future probably you will be on autopilot, but you will have an opportunity to drive for some time. So that's what I think.
So it's really nice to see you, Arun. I mean, I still remember your research was on the three-wheelers, right?
Yeah, that's
Vikram.
So
this is nice to see. I mean, especially when you meet your old students. I mean, when you find out where they wanted to be, and when you see them there, that really makes you feel really good.
Yeah, it's
been a long journey from three-wheelers to Volvos.
Yeah, I would say that's right. It's but I think it was good that I had a very interesting exposure there in the design program, at least from the beginning, trying to understand the whole process, like how it works, and then moving to finding out my interest areas. So that's a good thing about DP, where you do have the liberty and the opportunity to explore things, right? So
absolutely.
Yeah. So yeah, of course.
No, we have any specialization still, but then at least we have the opportunity.
Okay. So yeah, but as I said, like I do see that a lot of people actually straight away going into the IT domain, but I would say, of course, the automotive domain is also getting interesting. There are a lot of things to do in that area as well. So you just need some persistence in getting it to the right domain, especially the automotive.
So one interesting thing that has happened in the last 2 years is, so we have a lot of these collaborations with the aerospace engineering department.
Okay.
And so there is this company called VTOL. It's based in Bombay. They are investing heavily on air taxis. So,
yeah, that's right.
Yeah. So in fact, a lot of work happening in UAV segment also. But so two of our students this time, they're working closely with VTOL. Both of them are my research students. I mean, it's basically a sponsored project. So they're primarily working on the interiors and and it's an interesting thing because since it is fully automated, the way you design the interiors, completely different experience.
That's
and the most challenging part is basically that with these air taxis, and when you're talking about air taxi without a pilot, it's basically an autopilot thing. So convince the Indian users, the security aspect, safety aspect, oops, it's like it's a nightmare.
Yeah. That's right.
But then it's an interesting area that they're working on.
Yeah,
Of
because
course, UAV again is also another area that students are working on, which is quite nice. In fact, I mean, I must tell this to the students that Arun, when he was studying, there were other students also who were interested into mobility and all that, and everybody wanted to run behind cars and bikes and stuff. Arun was the only person, and trust me, I'm not saying that because Arun is here. But he was the only person, perhaps, who was interested in tractors. He was interested in buses. He was interested in public transportation. And that really, I mean, if you remember, we used to have these discussions about the importance of public transportation that way. And that really makes a lot of difference when you take up a particular domain which you really know and feel that there's a need to work in that particular domain. So I mean, automotive styling and all those things are fine, but then that also one needs to really think of. And you're absolutely right in saying that when you're talking about HMI, that definitely is an important area that people need to work in that area.
Yeah, that's right. Because at the end, the interest on HMI started when I was working at tractors. So that's what I figured out. Like when you have to have this, apart from styling, probably, yeah, this is something which is more, because right now I work with a lot of cognitive engineers, psychologists. So they have a very different perspective. So of course, psychology is one of the main, I would say, quite important for the designers, especially understanding, because at the end we are designing things for the humans. So probably you should know how they behave and what things they will do and so on. But yeah, on the UAV, the air taxis, I would straight away say, like, I think there was a white paper launched from the aviation industry in UK. So actually they did mention about this, the remote pilot and also the UAVs, which has been the air taxis, where they are actually focusing a lot of research effort on that area. So it could be good also where students start to look into those perspectives. So that will help them to get a lot of opportunities as well. So perhaps I can just write a note which is called, maybe they can actually have a look at it. It's called Chief Institute of Ergonomics and Human Factors, which is an association in England, in UK. So they do have a lot of, at least the publications related to the aviation industry and how it is evolving. So that could be also useful as well if someone is interested in the aviation industry.
Yeah. Okay, so I think we can.
Yeah, that was from mine. So it's just okay. Yeah.
Okay. Take care, Arun. See you.
Yes, sir.
I could hear a kid crying at the back.
I was about to say that actually.
Yes. Where is he? Yeah, I would like to see.
One second. Janu, I'll be back, sir. Just give me.
Yeah, sure. Take your time. I'll call ma'am. So I would like to introduce you to another instructor from next year. Okay, Arun is here. Okay, all right. Let's see. Oh. Hello.
So grown up. Hello. Hi. What's your name?
You have to unmute yourself, Arun.
Anu, say hi. Say hi. As I said, she's a bit sleepy, so probably.
Yeah.
Okay, now she won't. I'll show her something. Yes.
Anu,
look at this.
There is a cat.
It's a small tiger.
He's a small tiger there. See? And see there. Hi, ma'am. How are you?
Hello. How are you, Arun?
Yeah, I'm doing good. Thanks. How is Shoei?
Shoei is in Kolkata. She is studying there. All grown.
Okay.
Makeup. Yeah. Your daughter is this, grown now.
Yeah, it's Yeah, it's a long time, right?
Yeah.
And lots of good memories.
Yeah. Same piano. Yeah. So. Whew.
Sure, then take care. When do you plan to come to India again?
It's quite tricky now, sir. So probably next year, maybe end of next year, I think.
Yeah.
So that's the plan. But yeah, if there is any opportunity, I will try
Please
to.
do drop by. I mean, you don't need.
Right?
Yeah.
Yeah.
You just don't need any opportunity. You just need to give me a call and you're here. You're always
sir.
invited.
Yeah, sure. I will try to plan something next time when I'm in India.
Sure.
Okay, sir. So thank you very much for the opportunity, sir. But in case if students have any questions, it's just a thought. Like if they want to know a bit about like what kind of projects they would like to do, or if they are interested in HMIs, please like ask them to contact me. So I can actually guide them and help them. Yeah.
Absolutely.
Yeah.
Thanks, Arun.
Yeah. Thank you, sir. Take care. Bye.
Take care.
Thank you, Arun. Bye-bye.
Yeah. Thank you, Arun. Bye.
All right, for rest of the students, let me just quickly introduce you to Dr. Shatrupa Roy. She has come back. She was on a leave actually, and she will be taking your course next semester on design theory.
Hello.
Hello, ma'am.
Hi,
How are
Mrityunjay.
you?
I'm good.
So, Mrityunjay, I know now you are writing your thesis.
I am indeed.
Looks like.
If you'll, I can't.
No need for
You see that on your forehead. Yeah, it's always written.
Yeah, it's always written and also on the specs, I think. Chashma bada ho. Okay, chalo. So, when is the next session?
Next session is at 6 by Prithvi Raj.
Here, actually, what is happening is I am leaving for shooting tomorrow morning, early morning, 3:30.
Okay.
It's a crew of about 20 people.
So, that project finally started.
Yeah, that project has started.
So, okay.
So I have to go and do some stuff. We got this black magic camera and stuff. So we missed out on a stand for the handstand actually. So that I just got somebody to manufacture it. वो बना रहा है उसको ठीक ठाक कर रहा है. So I'll have to go and check. In case I'm late, I will definitely catch up. Get quickly started.
Yeah, sure. Yes, sir.
So tomorrow I'm going to Gorakhpur.
Okay.
About 7 hours drive from here, and we'll shoot tomorrow. We'll start shooting tomorrow at around by 3 or so. We'll reach there and start the shoot. And then tomorrow, full night. Next day morning, say sham tak chalega, and then we are back.
Wow.
Anyway, chalo.
Okay, sir. Take care, sir.
Yeah, take care. Bye.
Bye-bye. Bye.